First one. Name another angle that is 30 degrees. Now, the one thing we got to remember about angles is, okay, you got to remember it's the same arc is what you're going to be looking out for. Look out for the same arc. So this 30 degree angle here, what you'll notice is it joins from R to from R and Q is where that angle's formed from, isn't it? Is there any other angle that is formed from R and Q?
Yes.
The angle just underneath the 50, isn't it?
Yeah.
So another angle that's formed in between R and Q is this one here, S. So this one here, because they're on the same arc, they're both 30 degrees. This makes this angle 30 degrees. Right. Now that we have the 30 degrees sorted, what is the full angle? Full angle is 80. Now, this 80 degree angle plus angle X has to add up to what? Has to add up to 180. Therefore, X equals 100. That's it there, right? Easy when you know how, otherwise quite difficult. It's all about finding it's all about finding two angles that stand on the same arc. Now what I mean by standing on the same arc is, if you look at this one here, the one that I said is 30, sorry, excuse me. If you look at the one I said is 30, you can see that its angle points out towards Q and R. The other angle that's 30 degrees points out from P, and it goes from P to R and P to Q. So you can see that they're on the same. They both start and end in the same location. That's what you're looking to do. Alright, number 14. PQRS is a cyclic quadrilateral with PQ parallel to SR. If QSR is 33 degrees and SQR is 81 degrees, show that PS is the same length as PQ. Look at PS and PQ and you're going, huh? They're not, under any circumstances, look the same length whatsoever. What can you tell me about that triangle though? If they are the same length, what should technically happen to that triangle? What type of triangle is it if two of them are the same length? If PS is the same length as PQ, what has to happen? What happens if PS is the same length as PQ? This means this angle here equals this angle there. Would you agree with that? Isosceles triangle, right?
Right.
Yeah, okay. So, this angle here, I'm going to try and prove that this angle here, angle 1, equals angle 2. If I can do that, I'm in business. Okay? It doesn't look like it, but they actually will. I'll show you now in a second, okay? The first thing we can get is 33 plus 81 is 33 plus 81? Anybody? Anybody at all? 114. What's 180 minus 114? 66. This angle here is 66. What happens to this angle here? 66 and this angle here. What happens when you add them together? They give you? So if I take 66 away, I find out what this angle is here. And what is it? 114. Okay. Now I got that one. Okay, I'm in business. Now, $114. Now, does anybody see any Z's?
Yeah.
See the Z's? They're parallel, aren't they? This set is parallel. This means this here is 33, and that means this one up here is 33. Now we can find out what angle 1 is. And how do I find out what angle 1 is? Anybody?
Yeah, 114 and 33 and take away that.
Well done, Farrell. Add them together, and we get 140. And 180 minus 147?
33.
33. Both angles are the same. This is an isosceles triangle. This means that PS equals PQ.
So they don't have to equal each other.
According to the diagram, they don't. And the diagram is completely misleading in my opinion. So I'm not happy about that diagram at all. Farrell?
That angle SQ or no, OSQ must be like 66 degrees.
Oh yeah. SRQ is not 66 degrees. It's much steeper than that.
RSQ. RSP.
RSP is not 66 degrees either. It's much steeper. It should be close to 80 or 90.
It says 66.
It says 66 according to all the angles they gave me. I completely agree with you guys. It's completely misleading, but I've proved it, and the diagram is completely misleading. But that's the maths, and the maths doesn't lie. The diagram lies, but the maths doesn't. Next one.
Wait, how can you tell the two are parallel? PLS?
Because it puts that little line through it that says
PS and QR. Can you tell if they're parallel?
PS and QR. No, we don't know they're we can't say they're parallel because they don't have the arrows. Do you see the arrows?
Right, I have to do something to see if they are parallel.
They're not parallel because they're not parallel because do they have the same angles? 66, 144, 114. They're not parallel because they're not going the same direction. They're both going inwards, so they can't be parallel. They probably have opposite slopes, as in one of them's bending to the left the same amount, the other one's bending to the right, but they're not parallel.
She said the diagrams in the students so it's pretty good to tell.
I can tell because 66 is the same as 66 and 114 is the same as 114. Even though the diagram is misleading, the angles are still equal. The top left corner equals the top right corner and the bottom left equals the bottom right. So it would resemble something like that. Alright. Now, it's a good point though. Alright. Next one. The diagonals of the cyclic quadrilateral shown on the right meet at the point X. If AX equals XB, prove that AB is parallel to DC. I need to prove these are parallel. What can I do to prove that two lines are parallel? What's a great way of finding out if two lines are parallel? If I get a Z, and if I prove that this angle here equals this one down here, that's enough to say they're parallel, isn't it? If they're alternate angles, they're parallel. So what we're going to do is I'm going to first of all make this diagram a lot bigger, because the bigger the diagram, the easier it is for me to fill in numbers. So always give a really big healthy diagram when you're doing these questions. Okay, big healthy diagram. There. I think that's pretty big. Alright, now let's see what we're going to do with this, okay? I'm going to label them a couple of different angles, okay? So this is number 15, okay? Doesn't matter what you label. I'm going to call this one angle 1, angle 2, angle 3. Sorry, you can barely see the number 3, can you? Angle 4. What other one do I need? Angle 5. Angle 6. Stop there, okay? Now, angle 6 is the same as which angle and why?
2.
We don't know that yet. They are, but you're using the proof. We have to prove that they're alternate, so I can't use that yet. Angle 1 equals angle 6. Can anybody tell me why? Oscar? No, we said we can't use alternate angles. Angle 1 and angle 6. Are you looking? Where does angle 6 go to? Point C and point B. On the same circle, yeah? The same arc. They have the same end point on to make this work, both points where the angle ends, both points have to be on a circle, okay? And if the points where they end, so if I colour this in red, okay, if the 2 points end here, so you can see this angle 6 ends at C, which is on the circle, and ends on B, that's on the circle. I need to find another angle that does the exact same thing, and if I find another angle that does the exact same thing, I know they're equal to each other. Anybody have an idea about another angle that does it? Angle? So angle A. Okay. So angle A,
I mean angle 1.
angle 1, sorry, you're right, Farrell. My apologies to Farrell online, I'm sorry, Farrell. Angle 1 is angle 1. So angle 1 ends at point C and ends at point
Not called corollary 1.
B. Sorry? No, it's just called angle on the arc. Okay? So they're on the same arc. So what we can say is angle 1 equals angle 6, same arc.
It says in the book it's corollary 1.
Okay? Next one is we're going to find out another angle. Which one is the same as angle 5? Can anybody tell me? Angle 5? Angle 5 is going to be the same as angle 2, because angle 5 ends at D and A. Well, angle 2 also ends at D and A. So angle 5 equals angle 2 for the same reason. Okay? So, sorry, just give me a sec. Okay, so angle 5 equals angle 2. Now, what I have to prove is, I have two ways of doing this. I need to prove that either angle 6 equals angle 2, or I can prove angle 5 equals angle 1. I have to do either one of these to prove that the Z exists. I'm going to stick with, I'll stick with 5 and 2. Oh, sorry, 5 and 1 I mean. See the way? 5 and 1. Okay. What do I know about angle 1? Angle 1 equals angle 2. Okay. Angle 1 equals angle 2. So I can change angle 2 with angle 1. And if angle 1 equals angle 5, does that prove they're alternate? Yes, it does. And that's that question done. Okay. Alternate proven. Okay. Now they are alternate angles. And because they're alternate angles, this means that AB is parallel to DC. Okay, next one. The indicated angles measured in the diagram are equal in measure. Prove that QPS is a right angle. QPS is a right angle, okay? I'm going to label this one X, this one X, this one Y, and this one Y. Yeah, you happy with that? This full angle is going to be called what? 2Y. This full angle here. Now, can anybody tell me what is 2X plus 2Y?
2y.
Is 180. Reason? Opposite angles in a cyclic quadrilateral. Alright, you'd be forgiven for not spelling that right.
Doesn't that mean that you know they are?
I'm going to get there. Okay?
No.
Okay.
Hey.
Huh? Just give me a sec. Are you agreed that 2x plus 2y is 180?
Yes.
Okay, just stop there for a second. Both sides are divisible by 2, aren't they? Yeah? This means x plus y equals 90. Now, let's take a triangle. The top one or the bottom one. It doesn't matter. If x, we want to prove QPS.
Teachers, please leave your absence slips outside the door. Thank you.
QPS, okay, we want to prove QPS is 90 degrees. What's x plus y again? 90, isn't it? And what's 180 minus 90? So this means that this angle has to be 90 because x plus y is 90 and 90 plus 90 gives you 180. So next one. The chords AC and BD intersect at the point X as shown. Here. Prove that AXB and CDX are similar. Let's label all these angles. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6. Let's start off. To prove that these are Similar. Similar means all the angles are the same. I need to prove that angle 3 equals angle 4 for some reason. I need to prove that maybe angle 1 equals angle 5 for some reason. And maybe angle 2 equals angle 6 for some reason. Or it could be the opposite way around. Angle 2 could equal angle 5 and angle 1 could equal angle 6. I had to figure this out. First of all, why is angle 3 equal to angle 4? Opposite angles, okay? So there's a reason for that one. That's alright. Now what about the next one? Angle 1 equals angle 5.
They end in the same.
Same what?
And they end in the same places.
Same arc. Okay, they're on the same arc. So angle 1, you can see that it starts at B, goes up to A, and then back down to C. Angle D does the same thing. Up, across, and down. Angle 1 equals angle 5 for what reason? They're both standing on the same arc. And what about angle 2 and angle 4? Same reason, you think? Okay, let's figure it out. So angle 2 and angle 6. Angle 2 starts at A, goes to B, ends at D. This one can start at A, goes to C, ends at D. Angle, what am I going for? Angle 2 equals angle 6. Do you want me to go over that one again? Pretend you're starting at A. You go around to number 2 and you end up at D. Then vice versa, you start at A, you go round number 6 and end up at D. You're starting at A and ending at D. That means they're equal. Same reason. Angles standing on the same arc. Okay. Now, since all 3 angles are the same, hence, do you remember that little sign? Therefore, hence, triangles are similar. Okay. Next one, number 18 and 19. Okay. Okay. A, B, C and D are 4 points on the circle shown. Show that the triangles ADB and APC are similar. First of all, I'm just going to label our angles, okay? 1, we're going to label them both angle 1 because they're the same, aren't they?
Yeah.
What do they do here? Okay, then we're going to label. Why would I label all of this angle? Can anybody tell me? Why am I labeling it all? Because it wants the triangle ADB. It wants me to go from A to D to B back to A. That's why I'm labeling that full angle 6. I'll label this angle 1. Oh, sorry, not 1. Oh, sorry, not 6. Excuse me, losing it there. Angle 2. Angle 3. Yeah? And the other triangle, I won't use angle 1 twice actually, I'll use angle 4, but angle 1 and angle 1 and angle 4 are the same. This one here? Anybody? Why am I labeling 4, 5 and 6 there? Because they all belong to APC. Right. Both of these are triangles. ADB is a triangle and APC is a triangle. In ADB, angle 1 plus angle 2 plus angle 3 has to be equal to 180 degrees. Would you agree with that? Yeah? Also, angle 4 plus angle 5 plus angle 6 also has to be equal to 180. Yeah? Next thing. Therefore, angle 1 plus angle 2 plus angle 3 equals angle 4 plus angle 5 plus angle 6. Who agrees with that? Everybody happy enough with that? 3 angles in a triangle add up to 180. No problem there. Now, what Brian said is perfectly true. We already know that angle 1 equals angle 4. How do we know that? Tells us. Let's cross off. If I take away angle 1 on one side, I take away angle 4 on the other side. Now I got to prove that angle 2 equals angle 5. Yes, going here. So what we're going to get here is we're going to get angle. Yes, on the same arc, angle 6. You can see that it starts at A, ends at B. And likewise, angle 3 can start at A and end at B. So this means angle 3 equals angle 6. Therefore, angle 2 must equal angle 5. So if angle 3 equals angle 6, angle 1 equals angle 4, and angle 2 equals angle 5. What does that mean? Both triangles are similar. Now, not similar. Okay. Now that we've done that, how do we prove the following? AC multiplied by BD equals AD by BC or by PC. Do you remember what we did already in this chapter? We did enlargements, didn't we? If one triangle is the same angles as another triangle, what can we say about both triangles? One of them is just a bigger version of the other. Okay? There's one triangle. I think that's the triangle ABD. Now, ABD. Sorry. Okay, and the other triangle? APC. APC obviously not being as big. This is accurate as I'm going to get it, okay? Now, APC. What did we say angle 5 was equal to? Angle 5 equals angle 2. And therefore, and we already know that angle 3 equals angle 6. Now, let's do an enlargement thing. Pick a side. Remember, we always do one triangle divided by the other triangle. Which one do you want to do? Do you want to do large on top, small on the bottom, or small on top, large on the bottom? Large on top. So we're always going to do large triangle divided by small triangle. Pick a side that's in this answer, in the large triangle. This is the large triangle here. Pick a side that you see in the answer. Which side you see in the answer? AD, is it? AB isn't in the answer. AD is in the answer. You can choose AC or AD. Which one do you want to choose? AD. AD is stuck between which two sides? It's stuck at which two angles? The dot and the X, okay? This means that we're going to use AC, because AC is also stuck between the dot and the X. This will equal, pick another one, AC, because AC is in your answer. No, it's AC is, oh sorry, yep, you're right, AC is part of the small triangle. So AC is in the small triangle, which means it goes in the bottom. What side is the same as AC? AC is located between the dot and the... Shh. Lads, just give me a second there. The dot and the X, okay? Hey guys, we can't choose AC because AC is already there. It's AC is only there once, so we can't use it again. Let's pick another one that's in the answer. BD or PC. Which one do you want to use? BD or PC, guys? Huh?
BD.
BD, okay. BD, is that a big triangle or the small triangle? Big triangle. Big BD goes on top, and what's it? BD is going from this angle with the line through it to the x. Which one is that the same as in the small triangle? PC. Now you cross multiply, and what we'll get is AD multiplied by PC equals AC by, is that what I was asked to get? It is, but it's the opposite way around. That's proven. Okay? Finally, number 19. The so-called hardest one. You'll actually find it's the easiest one out of the lot. Okay? Have a look at number 19 there. Lads, what can I say about these two sides here? They're the same because they're both radiuses. What can I say about this one here? That's also there. Same. I have two isosceles triangles, don't I? Perfect. Next thing. What I'm going to say next is this is angle X as well. Yeah? And this one here is angle Y. See this full angle here? What's this angle in total? Can anybody tell me? It's X plus Y, and it's also 90 degrees. Why is it 90 degrees? Because its center is on the 180 degree angle. If your angle ends at the both points of a diameter, if your angle starts and ends at two different points of a diameter, this means that that angle you've just gone around has to be 90 degrees. No, it says prove that. So this means it's 90 degrees. Yes, James?